So we are looking at potential energy diagrams for multi-step reactions. And what is a multi-step reaction? We could call a multi-step reaction a reaction mechanism. Now, each step of a mechanism has its own activated complex. Okay, so each step has its own activated complex. And where do activated complexes occur on a potential energy diagram? Activated complexes on a potential energy diagram are located at the peak. So if each step has its own activated complex, then each step has to have its own peak, okay? So if you have 3 steps, you have 3 activated complexes, you have 3 peaks on the potential energy diagram. Okay, now the higher the peak, the slower the step. Does that make sense? Yeah. The higher the peak, the slower the step. Just like for if I was comparing 2 different reactions. If the peak was higher, it would be slower. If the peak was lower, it would be faster. We can actually find the activation energy for the overall reaction, okay? The overall reaction, the activation energy is from the reactants up to the top of the highest peak, okay? So for any regular reaction, it's from the reactants to the peak. For a reaction mechanism, it's from the reactants to the highest peak. So the overall is equal to the potential energy of the highest peak minus the potential energy of the reactants. The slowest step, which peak is the slowest step? Highest peak. The highest peak is the slowest step. Do a different color here. The highest peak is the slowest step. And that is the rate determining step. Hopefully that makes sense because the slowest step is the rate determining step. And delta H is the same as delta H always was. Delta H is the difference between the initial reactants and the final products. It does not depend on whether you have a 1-step reaction or whether you have a 3-step reaction. That difference remains the same. Product and reactant energies never change, okay? If a collision has enough energy to get over the highest peak, it will have enough energy to get over all the other peaks as well. So if we look at this, which of these 3 peaks, number 1, 2, or 3, is the highest peak? Number 1 is the highest peak. If a ball, like let's say we were bowling, okay, over the hill. If a ball has enough energy to make it over the first hill, it will make it over all the other hills. And it doesn't even matter that this one kind of dips down really far, because every time the ball goes downhill, what does it gain? It gains kinetic energy. So even if it goes really down far, it still gains kinetic energy. So it will have a lot of energy to make it over that last peak. Okay? Okay. So here we have our reaction, same thing as last day. We have 3 steps, 1, 2, 3. And that means that we have 3 activated complexes. 1, 2, and 3. So each peak is where you have each activated complex. Now remind me, what do we call a substance like Huber? Huber is a reaction intermediate. Okay, and where do we find Huber? Well, it comes right after the activated complex number 1, so it will appear here. There is Huber. Okay, and Hober, same thing. So reaction intermediates appear in the valleys. So activated complexes at the peaks, reaction intermediates in the valleys. Okay. Is there normally someone beside you? Yeah. All right. I was like, I'm trying to figure out who's away today because I'm like trying to keep it in my head so I can do the attendance later. I'm like, who's there? Oh yeah, it's Jeff. No, not Jeff. Jeff is in my other block. It's Daniel. Okay, Jeff sits there in block 7. Okay. I can't mark Jeff away. That would be a bad thing. Okay. All right. Reaction intermediates. They're produced in 1 step. So first, the reaction intermediate is produced, and second, it is used up. Now remember, those 2 steps don't have to be consecutive. You could produce the intermediate in step 1 and maybe use it up in step 3. That is okay. Okay, it could be step 2, but it also could be step 3. So this is just a reminder of what we did yesterday. To recognize a reaction intermediate, it appears first in the products and then later in the reactants. So first in the products, second in the reactants, and that is a reaction intermediate. Why are we reviewing this? Because we will see something else that comes first in the reactants and then later in the products. And we need to be able to tell the difference between the 2. Okay, so this is a reaction intermediate, first in the products, second in the reactants. Because now we are going to look at a catalyst, and we are actually adding on to the definition. Okay, last day we needed 2 things. Today we need 3 things. 2 are the same as yesterday. It is a substance that speeds up a reaction. How does it do it? It provides an alternate pathway. So that's the first thing you need, is that it speeds up the reaction by providing an alternate pathway. And what is special about that alternate pathway?
Lower activation.
The alternate pathway has a lower activation energy. So that's number 2. And the new one that we have not yet talked about is number 3, is that a catalyst does not get used up in a reaction. And that's important. Do you guys remember the matchmaker from the video? Yeah? Okay. The matchmaker said, you, get together with you, come together, go to the school dance. Okay. Now, did the matchmaker get used up when it paired those people up? No. Okay, it could be now like, okay, off I go, you and you, off to the school dance you go. And it could keep doing that over and over and over again because it doesn't get used up. It is used in the moment, right? It grabs one reactant, it grabs the other reactant, it puts them together. So it's being used temporarily at that moment, but it's not used up. So that's important because we can use a really small amount of catalyst to catalyze a large amount of reactant because the catalyst can be used over and over and over and over. Okay? So how are we going to recognize a catalyst? How are we going to recognize a catalyst when given the reaction mechanism? Well, you remember how the reaction intermediate was first in the products and then in the reactants? The catalyst is the opposite. The catalyst appears first in the reactants and then second in the products. And that's how you can tell it's a catalyst, because it comes out again, so it can be used again in another reaction. Is good? Yes.
Is there like a different way to like the catalyst versus like spectator ion?
You won't see, like, a spectator ion would be under other circumstances. You're going to be expected to see a catalyst in a mechanism. So you're going to have like step 1, step 2, step 3. You won't be looking for spectator ions in those. Okay?
I'm just asking, but I was wondering if there's like a different way it's written versus like spectator ion. Because I know it's just like what the same.
Yeah. Spectator ions would all be like in one line. Like it wouldn't be in 2 different steps. Like, so if you had a catalyst, it wouldn't appear in the same line. It would be like this one, and then it would come out in a later one. Okay? Yeah. Good question. Yes. Catalysts can be ions, but they don't have to be. They are often ions, but they're not necessarily. Okay? So Here's a side-by-side comparison. So you can see we have first on the right and then second on the left. That's a reaction intermediate, whereas a catalyst is first on the left and then on the right. The catalyst is not used up. Even though we produce the reaction intermediate, it then gets used up, so we don't see it again at the end. All right, you guys are going to try this reaction here. We have the uncatalyzed reaction, okay, and it is very, very slow. Then let's say we add a catalyst. The catalyzed reaction has 1, 2, 3 steps. Okay, so we started with a 1-step uncatalyzed reaction. Now we have a 3-step catalyzed reaction, and I would like you to identify any reaction intermediates and catalysts, and then check with your partner and see if they got the same thing as you. Yeah. No problem. Yeah, no problem. The lesson's recorded, so you can watch it at your leisure. Yeah, you have the review and everything? Yeah. Perfect, we're good. Okay. I need a new font. This one's too faint for the overhead. What do you guys think? Who is a reaction intermediate? HCOOH2+. Okay, we got one there. So that'll cancel out. Do we have any other reaction intermediates? HCO+. That'll cancel out. Do we have any catalysts? Yes, we have the H+. It appears first on the left and then on the right. So we can also, when we are finding an overall reaction, we can also cancel out catalysts because they appear on both sides. If we then add up this reaction to get the overall, shockingly, we have HCOOH goes to CO, because we got that, and we have an H2O. And guess what? That is the same as the original uncatalyzed reaction. So the overall reaction for a catalyzed reaction will be the same as the uncatalyzed reaction. It will just take a different pathway to get to the end result. Now, before we flip the page, we're going to draw a little picture down here. Potential energy diagram. And we're going to say that this is the uncatalyzed reaction. Now, if we were to add the catalyst, we're going to think, what would happen to the shape of this curve? What would be different about it? Have a little chat with your neighbors and see if you can figure out what would be different and what would be the same What would stay the same and what would change when we add the catalyst and we have the catalyzed mechanism here? Make Jonathan talk to you. And you guys could include Ryan too. Hannah, were you here yesterday? That's what I thought. I'm gonna need to make sure you get the review package and stuff, right? Yeah. All right, friends, where does it start? Will it start somewhere different, or will it start in the same place? Same place. Does anything ever change the potential energy of the reactants or the products? No, so it's going to start in the same place. Unfortunately, it's really hard to draw right on the line. So rather than drawing it like this, I'm going to draw it like this so you can see both, but it's on the same place. And it finishes at the same place.
Thank you.
No problem. Now, what should happen to the height of the peak? It should be lower. And should we have one peak or more than one peak? More than one. How many should we have? 3, because there are 1, 2, 3 steps, so we need 3 peaks. And which peak should be the highest? Which one should be the highest? The second one, because that is our slow step. So when it comes to the height of the first and the third curve, it doesn't matter which peak of the number 1 and 3 is higher. We just don't know. Okay, you can make them the same, you can make them different, as long as peak number 2 is the highest. Okay, so here we go. La, 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 la. La, la, la. Okay. Now, if we wanted the overall activation energy, where would we start and where would we finish? We would start at the reactants and we would finish at peak number 2. And I'm going to put cat here for catalyzed. Okay. Very nice. Now, if I give you a 3-step mechanism, you need to show me 3 peaks. But what if I didn't give you a mechanism? I just said I added a catalyst. And you're like, I don't know how many peaks. if you don't know how many peaks, it's okay to just draw one peak. But if you know how many peaks there are, you need to draw the right number, okay? I think it says that later on here, so I'm not going to write it down, but if it doesn't say it somewhere, then I won't bother. Okay, so here's our overall reaction. It's catalyzed with H+. Oh, we've done that already. There's this little aside, and aside means you don't need to know it. Do you guys want to go through this? No? Okay, excellent. Since a catalyst is not used up in a reaction, yes?
This is a weird question, but like for catalyst, wasn't it like for the last part where like you throw it out for the catalyst?
Yeah.
Since catalyst causes like since they lower like the amount of activation energy you need, and there should be like more successful reaction, but the amount of like potential energy converted to kinetic energy increase or
With the amount of potential converted to kinetic? No. Because the highest you get in terms of potential is here. And then, well, the only place we're converting potential to kinetic is when we're going downhill, right? And I don't know that that's even really a meaningful measurement. You know, like I don't know what we would use it for. So I wouldn't worry about it too much. Does that make sense? Okay, cool. Okay. So this just says, since a catalyst is not used up, we already talked about this, but here it says in the book, a small amount of catalyst can catalyze a large amount of reactant. And then they have the little matchmaker analogy in here again. I'm a little bit sad though, because I made it a woman, which is kind of sexist. Why couldn't the matchmaker be a man? Ah. All right. So to find the activation energy of a particular step, you start at the beginning of the step and you go to the peak. But to find the activation energy of the overall reaction, you start from the reactants and go to the highest peak. Okay, so for one step, you start at that step, the beginning of that step, and you go to the peak. Potential energy of the reactants, you go to the highest peak. Why don't you guys try this example here? When you are done, check your answers with your partner. Whoa. Yeah.
You're the same last name. I need to get that straight in my head, which is why I need to know the fucking one. So how's it going? It's good. It's good? Yeah. No, you just pass it, so there'll be like some small step. Yes. 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 Oh, okay, fair. But at least you were down the road. Yes. Oh, when?
like, it's got different flaws, right? So it probably wasn't really cooperative. Yeah, I started getting one for free, but, right? But if it's like, okay, how much that's about, then I'm trying to. Haven't helped you in having the third time, like, so unless, unless you're like, getting a note from the doctor, she'll just say, I'm just convicted. Blah, 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 right? Yeah. Any problem with that? And then, geez, I know I find. Yeah. But if at lunchtime someone marked on, yes. Because they're like, that's not fair, right? I'm so happy. I know, I was too. And then I like, oh my goodness, I was so mad at the girls. Anyway, so this was really hard for the test. And everyone else was writing their test. Basically, what I learned about all the older delinquents from like, oh, right? So what I and they didn't even check this for someone. Yeah. So I gave them all the card names. I put all of them in one class. And they started looking at me right sweating. They were like just, and they just look in their eye and they kept looking at each other, like one was over there, one was over there, and they're like, they had the ball, they had the audacity to come to me the next day and be like, I think we wrote that just before into the puzzle and it was not the error, and we thought that was fair. And I was like, I need you to think about that a little bit and see if you have something that you want to tell me. Well, I can't prove it. Oh, yeah, it's obvious, I mean, they achieved that, right? I knew it wasn't the same task because. Oh, yeah. Right, and the other thing is, yeah, which we put our companies was like, oh, yeah. Right, yeah, I get it, right? But one of them came to me afterwards and was like very apologetic, and just like, you can tell that he felt like, no, he was like, oh my god, I've done wrong. Other one came and apologized and was like, oh, I'm so sorry, I feel so bad. No, but you can tell he wasn't sincere. Right? So I'm like, this one is a big interesting. Like,
All right, friends. How many steps in this reaction mechanism? 3. And which one is the rate determining step? 2. And where would we start for labeling the activation energy of the second step? At the beginning of the second step. So this would be the activation energy of step 2. Activation energy of the overall reaction. We would start from the reactants and we would go up to that peak, and it's kind of hard to draw them all in one place. So I'm going to do like this, and I'm going to say that's my activation energy overall. Delta H, is it going up or down? Up. The axes, what goes on the y-axis? Potential energy in kilojoules per mole. And on the x-axis, we have the progress of the reaction. You can have reaction proceeds. Someone said, can they have progression of reaction? That's fine too. Like, as long as you're saying the reaction is going on, that's basically fine. Where do we put our activated complexes? At the peaks. So those are our stars. Where do we put our reaction intermediates? In the valleys. And that's all we needed to do. Okay. There we have a solution. This is just we already drew one like this. You guys did that already. We had an uncatalyzed reaction, and then we had a catalyzed reaction with 3 peaks, right? So this is good. If you are not given the catalyzed mechanism, 1 peak is okay. But if you are given the mechanism, you need to draw the right number of peaks. This is now page 95. So what are you doing for homework? You are doing 1.3, 1.4, 1.5 so that you feel good about everything. We are done. So we have a half an hour to actually work on things. I would suggest one really good skill to practice right now would be 1.4C, because it makes you practice adding up the reactions. I would say, especially before you leave today, try number 4 because it's a find the step, and those are harder. And try number 6 because it again is a find the step, and those are harder. So make sure you've tried those before you leave so you can ask questions if you want to. All right, we have a half an hour to work. You also have the overall review if you want to use it. We will not be having an overall review day in class. No review day. Okay, you have 4 days this weekend, and I know you have other classes, so split up your time well. Okay, say I'm going to work for an hour on chemistry, and then I'm going to take a 15-minute break, and then I'm going to work for an hour on calculus or whatever it is. You know, split up your day, go for a walk in between, you know, hydrate a lot, take good care of your body so your body can feed your brain. Okay? Yeah. Yeah. We're going to start the next unit. Yeah, for Wednesday, Thursday. Oh, but I will, Wednesday, Thursday, and if there's any time on Tuesday, I will be answering questions from the overall review if you've done them. So if you're like, I don't get why 39 is the way it is, we can do that. Okay. Okay, so that'll happen, but I'm not going to give you time to like do the unit class. Yeah? Yeah. You want to do really well on this test because it is the easiest one of the year, so it will set you up well. If you don't study for it, then you'll be like, oh, I didn't set myself up well, and now I only have harder units to look forward to. Okay? So do as well as you can on this one. It'll give you a good starting point. Okay. That's a really good idea. Yeah, okay, you let me know if you need anything from me. You can just email me over the weekend if you need anything, okay? Yeah. Over there. Oh, you know what it is? I've actually turned off the main. It's probably in the piping of the Bunsen burners, but it's probably not helping how you're feeling, I imagine. Yeah, no, you're good. You're good. No, we're good. But yeah, thank you for letting me know. I appreciate it. Okay. Is there anyone else who needs an overall review? I'm going to print an extra copy because I ran out. Huh? No, that's the outline.
And I have the overall.
Yes.